All right, guys, we're gonna start now. Thank you guys all for coming. Welcome to the first ML Explore workshop. My name is Alex Sanchez. I am a senior studying computer science and mathematics, and right now I'm doing research here at FIU on multi-agent systems. Kang is also an instructor with us.
Hello everyone, my name is Kang. I'm currently a sophomore junior studying computer science at FIU. I'm an incoming AI researcher at the FIU Applied Research Center.
And yeah, we're excited to get started. First, we gotta go over some logistical stuff and make sure you guys check in. That's really important. I'm sure most of you already have. And yeah.
Did everyone check in yet?
Everyone checked in?
Yeah.
All right.
Okay.
And then please scan this QR code. This would be like an entry survey. I'll give.
In order to receive the merch from the last workshop, you have to fill this out. This is how we're going to keep track.
Yeah, so I'll give you guys a couple minutes to fill that out, and we'll get started. Okay, so we're gonna go ahead now and
Yeah, so you here have not heard of it. What's your opinion? Everyone's opinion then? Fine if you could. Okay.
that's just,
Can you just we'll talk about it. But Explore is one of the programs that we did. It's a software that cover like the fundamentals of programming. So this semester we had web development. Web development actually starts next week. But yeah, like this one, hardware, in-depth, cybersecurity, and have UI and UX if you want. So if you're not yet a member, I would recommend just that link. Completely free, open to all students, who are major. It's really, really good. Highly recommend it because it allows you to connect with other students that are also from tech industry and also attend all of our like workshops, events, and yeah, highly recommend it. And these are some numbers of the impact of the flex. We have over 5,000 members. We have over 3,800 alumni that we connect with in Discord. So yeah, it's super helpful if you're trying to help or tips or
yeah. So briefly, what is AI ML Explore? We're gonna go over some fundamentals of AI, especially this workshop. This first workshop, we're gonna go over what AI is, what ML is, deep learning, all of those things, and then throughout these workshops, we're gonna build a really cool project that involves computer vision and essentially answering the question, how does a computer see the world? In the same way we do, how we replicate the way we see the world through a computer. And we will have 5 workshops. This first one, again, ML fundamentals. Second workshop, we will focus more on neural networks, and from there on, we will build our project through object detection, in this case, player detection. Then we will separate what a player is, what a goalkeeper is, referee, the ball. And then we will have a special last workshop in which we will project that 3D visual space of a soccer game onto a 2D field. And yeah, so this is an example of how our final project would end up looking like, and we're really excited for that. Yeah. So,
Thank you.
that's it, end of workshop. So, no, actually, I need you guys to go to the Notion. To get to the Notion. In the Notion, we have a Colab notebook in which you guys will be able to code along with us. And we also basically have most of the information there. So,
Yeah, I just posted the Notion inside the Explore cohort Discord channel. Let me know if you guys can access it.
yeah, so go to the Notion. When you go to the Notion, there we have basically all the information you're gonna need throughout these workshops. Room, number, time, days, everything. And also under this session 1, Intro to AI and ML, we have this Google Colab link. Go ahead and click on it, and it will take you to this page. Let me know if you guys need help getting to that point. Yeah. We sent it on the Explore. Oh, the Explore cohort on the Discord.
Oh, I think you have to select the Explore cohort when joining the server.
Oh, okay. Don't worry. Let me know when you
I think you
whatever.
can go to channel and roles on the top.
Where's the If you're having trouble accessing that, you can go to go.fiu.edu/explore hub, as I have it up here. If you guys are having trouble through the Discord, going through here, this will send you to like the Notion of all the Explore workshops for in it. And there, if you scroll down, go to AI ML, and this will take you straight to our Notion. So yeah, there's 2 different ways to get at it. Raise your hand or like yell out my name if you need help with that. So you could also go to go.fiu.edu/explore hub. Go to, yeah, but at this point might as well just go to like go.fiu.edu/explore /explore. That should take you right to like, I guess, the central node of like all the Explore stuff, and then look. No space. That should be good. Yeah, and there scroll down until AI, or yeah, you could also go Explore Hub. Scroll all the way down. Yeah, get out to this page thing. Go to 2026 Explore. Yeah, you're good there. Now scroll down there. Like down, scroll up, I guess. Yeah, it doesn't scroll up. Interesting. You have. Try it again. Go to. Okay, I got you. Go to Explore Hub. This seems like you were just like in that spring. And here under AIML, make sure it's under Spring 2026, and go to like the documents. You'll have everything under there.
You have access to the Notion.
That's what I just asked.
Yeah, for your resume. Yeah, that's good. Yeah. It's every Tuesday. Every Tuesday. Yeah. Call me over if y'all need help for anything. No problem. Is everyone good? Okay, make sure to go to the Colab notebook and we can start from there. Yeah, so Google Colab is basically this cloud platform where you can access different GPUs and TPUs. This is very helpful, particularly in machine learning. When we're training these models, we need high levels of compute. This gives us direct access to Google's TPUs and GPUs, as you can see here. And also lets us just have like a joint environment to code in. You don't have to download anything, and yeah, it's just straight on the cloud. But we could get started now. So just to start off with, what is AI? I actually want to like ask you guys this, like what AI is to you, what definition you guys have in your head. If anyone wants to answer that, what AI means to you. That's a good answer to that. I mean, it's a really multifaceted question, but that does encompass a really big part of it. And yeah, AI, at the end of the day, the whole art of AI is us wanting to replicate human intelligence, right? And through different systems and different ways, we try to replicate or mimic our intelligence. And right now, we're even trying to surpass it. We could say also that there's different types of AI. I mean, you guys could use ChatGPT as a chatbot. You guys can have probably seen like, I don't know, Siri as a voice assistant and things like that. Right now, we're trying to reach a more generalized form of AI called strong AI that basically just is super intelligent in a way that it can encompass all of these different things, right? It's not just a computer vision model for detecting images or a text generation bot. Under the same model, it does all these different things. And under AI, right, AI, it could literally be a bunch of if-else statements. That could technically be AI, right? But recently we have kind of focused as a society, I guess, onto machine learning, which is like basically AI learning from data. And go ahead.
So traditionally, we program and give the machine like explicit rule of what it need to do. So it's run line by line. But for machine learning, it's different. Machine learning is basically you take the machine and help it learn from data, and then it learns the pattern inside the data. And after that, we can make it do certain tasks that we want, such as prediction, classification, and furthermore. So yeah, we're not really explicitly telling what the machine learning, the model, what it needs to do, but rather than make it learn from the data, all the pattern of the data, and then let it do the job. And in machine learning, there is a lot of subsection. So as you can see right here, on the left image, under the machine learning, we have deep learning. So that is what we are going to more focus on later on in the workshop series. And we have different type of learning: supervised learning, unsupervised learning, and reinforcement learning. We are gonna go over that later on as well in this workshop. And under that, we have all this different different type of algorithm as well, and such as classification for classification task, regression for prediction task, predicting house price. Clustering is also a clustering. Sorry, no, it's like clustering.
Clustering, this is essentially like when we want to group similar data points or groups of data together. Like for example, if you just throw at a machine learning model like a bunch of pictures of animals, you want to cluster the dogs with the dogs, you want to cluster the cats with the cats, and in that separation, it can, or through that abstraction, it will learn, okay, the things in this graph that are towards the dog part are probably a dog, towards the cat part probably a cat, and things like that. And that's kind of the technique that we will be using to cluster once we detect in our project, like a soccer player analysis project. When we want to detect a player and separate what a player is from a referee and separate what the referee is from like the ball itself, we will be using clustering techniques to be able to group these similar data points together.
Yeah, and all the boxes you see down here are all the different algorithm that we can like different. They call it different models for different use cases. Each one of this have the advantage and disadvantage. So depend on your tasks, depend on your goals, you're gonna choose between these kind of algorithm to choose which one the best that fit your best need for the like matches with your final goal. Yeah, so we often hear about train a model. So what is exactly is so in machine learning, a process of training a model consists of well, usually it's 4 to 5, but if we want to improve the model and then deploy it, there is 7 stages. So the first stage is when training a models, we need data, and in order to get that data, we need to gather the data. Sometimes we have to manually collect the data, but now we have website that already have pre-existing data set so that we can use to train our model, such as like Kaggle or the one we're about to use, which is RoboFlow, which is a website that focus on computer vision. They have a lot of data set for computer vision tasks, and also we can deploy our model on there as well. And they also have a lot of pre-trained computer vision model on there as well. We can download. Yeah, and after we collect data, what the next step we do? We prepare pre-processing data. So most of the time, the data we collect is not perfect. It's not organized. It's not always like fill up all the way through. Sometimes some part is missing inside that data set. So what we have to do is that we have to, what they say is clean the data, which is we need to make the data more organized, less unstructured, like make it, they have no, so like in the data set they have, sometimes they have a lot of null elements, so we need to get somehow have the data set minimize the amount of no data they have inside the data set as much as we can, so that we have a good data set to train on. The better your data set is, it really impact a lot on the performance of your model. So this is also a very important stage of when you train a model. The third step is to select the model. So as I said before, they have a lot of type of models or algorithms we can choose from depending on the tasks that we do. So for example, housing prediction. For that, we can choose a regression. So I can choose linear regression models or neural network regression or random forest regressor. I can choose from different type of those algorithms and try them out to see which one like fit my best need and fit my final goal when training a model. And the fourth step, which is the actual model training. So now we have the data set we pre-process, and the data set now look beautiful. So now we feed that data set into the model that we choose, and the model will then learn the pattern inside the data set. And then after it learns, then we can start to evaluate the model on the new unseen data that we haven't shown them before, to see the performance of the model, how good it is on like actual testing on like new example, new data. And if the model, after we test the model, after we evaluate the model, if the model is not performing too well, the accuracy, let's say our goal is to like have more than like higher than 80%, but it's like 60%. So we go back and we fine tune the model. They some so this process of fine tune the model is either sometimes they either look at the data set to see if it most optimized, most like clean, and then if it is, then they start looking into fine tuning. So what's fine tuning? Machine learning model, you can see it as like a function and or a method, and this method take a lot of parameters. Each of those parameters is very important when you train the model. It determines whether your model is performing good or bad. So fine tuning is basically twist or change those little parameters so that your model will be performing better. Or they also say hyperparameter tuning, which is they indicate that we twisted the function parameters, the machine learning model parameters, so that we have a better result. And then after that, after you fine tune, then you come back to model evaluation. And then if you see it not increase as much, you come back and fine tune again, and then you do that process until you reach to a point that you say, oh, this is good enough. Then you go ahead and then deploy it or do whatever task you want. So after you want to predict the housing price of Florida, you make a website for it, and now you can use that model and connect it to your website, and then start predicting housing price for Florida. So type of learning, there's different type of learning and machine learning. So the first type of learning is supervised and unsupervised. So what supervised is that the model learn on label data. So for example, my task is to train this model to classify whether an image I give them is a dog or a cat. During training, I will give them the image of a dog or a cat, but then I also label each of the image as, oh, dog, then I label as dog. The image is cat, then I label as cat. And then train the model with the image and with the label. Unsupervised learning is when we train the model without label data. So at this time, I only give them the image without the label. So why do we do that? Why do we train a model with an image that have no label? Isn't that gonna increase the difficulty when we train a model? The reason why this was existed is because label data can get very expensive and time consuming. Label data, we need someone to actually go through the data set and then label each of the data. And to get that big, sometimes we train the data set, it's not only 100 or 200, it's 1,000 or 10,000 of data. So it's very time consuming and expensive. So that's why unsupervised was created. Semi-supervised. Semi-supervised is the combination of supervised and unsupervised. So what it does is that, let's say for the first 70%, when you train a model, you're gonna train the model with no label data, unlabeled data. And then for the rest of 30%, you train the model with label data. So for example, at first we're going to feed the model with image of dog and a cat so that it learned all the feature like the leg, the ear, the facial structure of the dog, and how the facial structure of the cat look like. And then after that, we're going to feed the image of a dog and a cat with the label dog and cat, so that it can finalize, it can like increase the accuracy of the model without spending too much on the label data. This is the alternative way to approach when label data is expensive and time consuming to make. So that's why it was created, to also not spending too much money on data and time on the data, but also have decent accuracy. for the model. Reinforcement learning, this is little different than the three we just went over. So reinforcement learning is for so when an agent, we have an agent and we have it interact with the environment, and we will give it reward or punishment depend on the action it took. So let's say I have a model, I have an agent that I'm trying to make it play chess. If I have a knight, which is I can only make an L move. If it's supposed to go up 2 and go right 1, but let's say it's go up 1 and go right 1. So it break the rule, and I give them punishment that don't do that again. So the next time it learn and it do, go up 2 and go right 1, which is follow the chess rule. And here is regression classification.
Yeah, so a lot of this talk through machine learning is that we want to have a model that predicts the future based on past data, like past experiences. So regression, for example, linear regression, let's look at this example right here. We have a bunch of data points. Let's imagine the y-axis would be like let's look at here. Let's imagine that the y-axis would be like the temperature, the x-axis is the day. So on day 40, the temperature was like 60 something degrees, and those are like our data points. We want to predict using that data. Let's say we want to predict the next day how the temperature would look. This is really simple, actually. You guys would like, who here's aware of like y equals mx plus b? That's like, like bare bones, just algebra type thing. That's essentially what linear regression is. I want to say that machine learning and all of that, it seems very complicated, but behind the scenes, it's really just a lot of math equations. So in this example, you guys can run this code if you guys want. With shift and enter, it would run the specific cell and then take you to the next cell. So in this case, for example, who here knows Python? A few of you guys? Okay, so I'll make sure to talk you guys through the syntax of Python. In this cell right here, we're just importing the tools that we're using. For example, NumPy, it allows us to, it's basically a high-level math module, and Matplotlib is a module that allows us to graph things and to represent visual data. Scikit-learn, linear model, here we're importing linear regression, so we're importing the model itself, right? And here we're making our own data set in a way, right? So we have day 1, day 2, day 3, day 4, and then each temperature here corresponds to the day. So let's say on day 1 it was 72 degrees, day 3 it was 71 degrees, etc., etc. This is us just making some dummy data just to have a look at what linear regression is. Here we define our model. So our model is a linear regression model. And .fit means that with the data that we were given, with the days 1 through 10, and then the temperatures here, we fit. So that is basically the training of the model. And we want to predict the next day, which is day 11. What would the temperature on day 11 be given the previous 10 days, right? And the reason I brought up like y equals mx plus b, I'm going to show you guys right here. Given the data points, for example, again, day 1, it was 70 something degrees, and all the way till day 8, it was 90 degrees, and we want to predict day 11. What we do is we try to find the best fitting line that represents that data, right? If we had a line that started here and then ended up here, if you guys can imagine this, it wouldn't really represent our data. So when we predict a model, in this case in linear regression, we are trying to find the most optimal slope of the line that fits this data. And we can properly assume that given the trend of the past 10 days, this is where our next data point would be. That is what simple linear regression is. And again, that was regression, that was predicting the next value based on past data. Another thing that you can do um, with machine learning is classification, right? So instead of trying to predict the next day what the numerical value is of the next day, we can give something a class. So let's say anything under, I don't know, anything under 80 would be considered a cold day. Anything over 80 would be considered a hot day, right? So here we have temps. This would be an array of our temperatures, right? 65, 68, 70, whatever. And then is hot is basically telling us it's just a binary, a list of just binary variables, right? Is 65 degrees a hot day? No, 0. Is 85 degrees a hot day? Yes. That is our dummy data that we're using. So again, here I'm importing logistic regression, and we make the classifier. And here we use the classifier, and again, we predict. Using our input temperatures, we want an output. Is this hot or not? And now let's give like tomorrow's temperature in our dummy data. Let's say it's 81 degrees. And we want to predict the probability that 81 degrees is hot or cold. And then if the probability is over 50%, we say it's hot. If it's under, we say it's cold. And don't worry about the code here. This is simply just to plot a graph. And this is our graph of that data. So what does this graph show? This shows our data here and the probability of being hot. 81 degrees is the data point that we wanted to predict whether it was hot or not. And this little gray line, see it as a decision boundary. Anything above that line would be considered a hot temperature. Anything under that line would be considered a cold temperature. Again, this is all given the data set, the little data set that we made. And from that, you can classify into different classes what our data represents. So again, 81 degrees, we can consider it a hot day based on prior data. And yeah.
So we just talk about how linear regression and logistic regression now it's overfitting and underfitting. So what is overfitting and underfitting? Overfitting happened when the model learned the data too much, basically. So it's not learning anymore. It's learning too much that is actually memorize the data rather than generalize on the data, rather than learn from the data and then answer question, but now it's memorize the data and answer the question. So it's very dangerous for the model to do that, because if we give it a new unseen data that I haven't seen before, most of the time it's going to perform very bad, because it memorized the training data, and we give a new data that was not in the training data set. So now it haven't seen it before, so it haven't learned from the training data. It actually memorizes the training data, so when see a new data, it's not going to perform very well. The accuracy is going to be very low. So we wouldn't want our model to be overfitting. We want it to learn rather than memorize the data. What's underfitting? Underfitting is when the model is not learning too much, when it's learning very little. So as you can see the image right here, this right here, the data, the pattern of the data is look like a curve or a banana. Rather than learning the data, it only learn like a straight line, rather than adapting to the data. So it's not learning the data too much that is making, like, it's not learning too much on the data that is making the learning curve like this shape as well. So it's not going to perform very well on the testing data either. So both underfitting and overfitting is dangerous when we talk about machine learning, training a machine learning model. So how do we know what's the middle where it's not learning too much that is memorize the data, but it's learning enough to perform a task well. That will be like looking something similar to the middle image, where the model is adapting to the data, where making a curve like a banana shape right here, rather than overfitting, which is like adapting to the memorize the data. So you see is zigzag to every single data point. It's more generalized. It's learning the data, but also not memorize the data. So that is what we trying to aim for when we train a model. Before I go to the next one, anyone have a question? The next step, the next thing I'm going to go over is evaluation metrics and train test split. So evaluation metrics. After we train the model, we want to evaluate our model to see if it's performing well or not. And a way to determine whether it's performed well or not is through evaluation metrics. What evaluation metrics does, most of them, is basically compare the model prediction answer with the actual answer, and then see how wrong the model is from the actual answer, and from there just give us a number that represent, oh, the model was not performing too well by this much. That's just the general idea, but going deeply into evaluation metrics, we have on the left side we have regression evaluation metrics, and on the right side we have the classification evaluation metrics. Each of this, all of this is performing the same idea, but the number we use each one of them depend on the cases where we need to interpret the model in different way. So let's say I choose MSE for a case where I need to interpret for person A, but then I need to use MSE to interpret the model performance for person B. So really just depend on your cases, depend on your need when interpret your model performance. So I'm gonna go dissect one of the evaluation metrics today. That will be MSE psyche. Okay. So what does MSE stand for? MSE stand for mean square error. So mean, most of us probably know, is the average of something. Square is exponent to the power of 2. Error was error mean. In machine learning, error mean error mean how far off the model prediction was from the actual answer. So for example, my model prediction was, let's say, 8, but then the actual answer was 4. The error in this case will be 4. 8 minus 4, 4. It's basically saying that the model prediction was, let's say, 4 units from the actual answer. And that's basically what the error is. Sometimes people say with loss as well, but sometimes people just mean the same thing. Yeah, the equation looks something like this. 1 over n. So this is an equation for mean square error. I'm gonna go over and take out these ones. So what does this mean? Yi represent for the actual answer. Y hat represent prediction, the prediction value that the model gives. In this case, what we really do is we calculating that error. We're calculating how far off the model prediction was from the actual answer. So I'm gonna take 8 and 4 in this case as our example. My prediction was 8 and my actual answer was 4. So 4 minus 8, which is -4 in this case. After that, the next step will be taking the square of that result. So we take the square of -4 and we have 16. And then what the next step is taking the summation. So when we train a model, we not only train it on only one single data, we train it on a list of data. So what this does is that like for each of the data that we have in a training data set, we compute we feed it to the model and we compute the prediction value, right? So, and then if we go through the whole data set, we're going to have a bunch of prediction value. And so what the summation is that for each of the prediction value we have, calculating the error, and then adding all of the error after we calculate, adding all of them together to get one sum error. So that's what the summation do in this case, is to sum the error of the whole data set. After that, we're going to do 1 over n. What's 1 over n? 1 over n is basically let's say the total error, value of how far the model prediction was from the actual answer is, let's say, 100. And my data set, the amount of data I have in that data set was, let's say, 20 data. So what is n? It will be the length of the data set, which is 20 in this case. I would take that. 100 is the summation, the result for this will be 100. And after that, I got this. I will apply the 1 over n to this 100. We multiply. 100 times 1 over n will be 100 over n, right? And then what's n? N, we said before, was 20. And then we're going to divide 100 by 20. And then we have 5. Yeah, 5. So why we do this? We do this to calculate the average error, the average unit, the model prediction from the actual value. We calculate that average error to later on take this and interpret that, oh, I just applied this evaluation metric, or I just applied this evaluation metric, mean square error, and I see that I have, for my model, the average error was 5. So basically saying that my model prediction is, for average, is 5 units off from the actual answer. So yeah, so that was MSE is, but coming back to evaluation metrics. As I said before, all of this is performing basically the same purpose, to see how far off the model prediction was from the actual answer. So, but each of them we use for different cases, different purposes. So, before you want to use like any one of them, just search up which one. Just you can search up and then see what each of them usually used for, and then you can select which one best fit your need. Then we go ahead and talk about train test split. So I talk about data set a lot, but are we training and testing on the same data set? No. The reason why is because when we train on the same data set, okay, the model learned the pattern of the data. Now, the model is ready for tests, and now we're testing the model on the same data set. It's like you have a midterm tomorrow, and then the professor gives you the study guide. All the question in that study guide, you did that, and then your professor go over with you what the correct answer is. Next day, when you walk into a midterm, all the questions are the same. So you basically memorize what the answer is, and then just go ahead and fill out the exam. So when doing that, it can give back feedback that the model was 99% right, 99% accuracy, 100% accuracy. When I say 100% accuracy, that is actually a red flag. So you should come back to see your data was leaked or not. But yeah, so it get false report of your model performance. So that's why we need to split up the data set when training and testing the model. When I talk about leak, it's like leak in data set is as I talked before, was train and test on the same data set. That's usually leak. And then train test split. Now in the data set, we need to split up the data set into usually we split up the data set into two parts: training data set and testing data set. So people usually do 70% and 30%, or 20, 80, 60, 40, depends on your choice. But let's do 70% and 30. 70% will be the training data set, and 30% will be the testing data set. You will be training your model on the 70% of the data set, and then after that, you want to test your model, evaluate your model on the rest of the 30% of the data set. That's allow the model to train on a data set, but then test on the new unseen data set without being leaked of what going to be on the exam, as we used before with the example. And in the picture I show here, a better way to do this will be actually split into 3 parts rather than 2 parts. We want to split into obviously training set and testing set, but then we also have a validation set. So the reason why we have this is that to eliminate the chances of the model have a kind of idea of what the test gonna be on. So or we eliminate the chances of the data being leaked to the model. So why are we doing this? So for example, if you, in the case where you train your model on the training data set and then you test your model on the data set, if that was the case and you don't want to, you train your model on the training data set and then test your model on the testing data set, and then you see the accuracy of your model and you say, I need to fine tune it. As I said before, one of the steps was fine tune it, or help the model learning better. So you go back and then you fine tune the hyperparameter, and then twist them a bit, and then you go ahead and test it on the same testing data set. Sometimes the model can get a little bit leak of the testing data set, and it actually starting to learning the testing data set, which is what we don't want the model to do, because training data set is for training, testing is for testing. We don't want both of them to be mixed up. So that's why we have validation set. We train the model on the training data set, and then we validate the model on the validation set. After that, we see the model performance. Let's say it's not too well, we come back and fine tune it, and also after that, we validate it on the validation set. We keep doing it, the loop, until we say, oh, the model have a decent accuracy. We go ahead and then test it on the testing data set. So that's in that way, in that sense, we only use the testing data set once, and then eliminate all the chances of the model having an idea of what the testing data set will be on. It's like you have to take a look of what your test going to be on, and you go ahead, go home, and then do a research, and then go ahead next day to exam, and then answer the question. That's not what we want when we train the model. So I have an example here. I want you guys to try out. You guys can go back to the Notion docs, and I have this here. It's a CSV file. It's a dataset file. You can download this, and then yeah, you guys can download it. It's right here, and then you guys go to over here. Open up the dataset you just download, and then just pass it into the sample data folder, which now it will be in here, California housing price. And then you can go ahead and start running each of the cells.
If anyone needs help downloading, just raise your hand. I'm around. Okay, so you have it. Yeah. Can I? How? Hold on. I wonder if in one of these files you're supposed to sample data. I don't know why your collab immediately kind of shot out. Whoops, I'm playing around too much, but yeah. So
okay, so
import it. Yeah, import it into here. Go to like the file you downloaded, kind of just drag it in there. I'm sorry, I don't know much about Macs, like so, but principle is still the same. So go to downloads and
you're able
like,
to
kinda
download
drag
this
it into it. It should work.
Co-op? Oh, it was in the Notion. Yes, right. You can click the drop down menu, and it will be like right here, and that will be the data. Was you able to?
Okay.
Oh, yes.
Go to
so you can open the Google
go
Colab
to like where it says sample
which
data.
is what we have on right now. Which is yeah. Oh, you have to download. Then you can go ahead.
It's like all the way
Colab
off to
notebook.
the side.
Yeah.
Have you?
That's because I was playing around with it. I'm sorry.
Touched on
But-
Colab notebook before.
Right there. Yeah.
What is
Sample
this
data.
actually?
Try to drag it
just
into that
a
folder.
cloud platform where you can run your code cells by cells. So
Test.
have
And
you
let me
programmed
see.
before? Little.
It's called
So
California Housing
in
Price.
a
Yeah. So
like in a program environment,
it's
when you
not the
click
same.
run,
So
your program is going to go from top to bottom, each
yeah,
line by each
just
line.
drag it. Yeah.
In this case,
Drop it in.
you can't actually control which of the
That's
line will be
all
running
that's saying
first.
is that when you disconnect
So
from
let's
the
say-
GPU of
let's say,
like Google, it will just delete that file.
when I
That's why
click,
we have to kind of
like usually
do that
on
whole
the
process.
other development environment, I click run. It's gonna be run
Yeah,
from top
you
to
should
bottom.
be able to
I
run it
cannot
after
do
that.
anything.
Let's test it
I
out.
cannot change how it's gonna the order of which it's gonna run. But in this case,
Yeah.
I can just
Another thing
run
with
this
these notebooks,
first and then run this.
try
later.
running it.
I can completely ignore this line.
If-
Which is
Yeah, run anyway.
very useful when you just want to try out
Okay, Perfect.
like
Yeah, so what that did
coding
was
each
it just
part,
read
and
that
then you want
CSV
just
file,
trying out each part.
and
And in machine
here
learning,
we're like splitting the
AI,
data
machine learning
into
field, they
the
often
training,
use
validation,
this
and the
type of
testing
notebooks to like
data
just testing out models
data
and
set.
testing out research as well. And
Yeah.
yeah, we have all the information here that we just went
Okay,
over.
so regression, regression,
then-
it's
and
kind of a way
like
to describe what type of
run-
prediction we're doing.
Yeah. you can
So when
run this.
we're regressing something, it would be like when we have continuous data points. Imagine, go scroll up to like the like right here. This would be a regression. We have a bunch of data points, and we want to find a line that best fits
a library,
those data points. And that way, when we have a new data set or a new data point, it will try to best predict that new data point that we add. In this case, you see how it keeps going up?
that you can use.
If we add a new data point,
We currently
due to the past data that we have, we can say that the trend
that
is that it's going up, right? So we can safely kind of assume that the next data point will be up here. That would be an example of regression. Now, the reason that
take them to
let me
use
see. Been standing
take
too
one
long.
of the tools from out that folder, which is linear regression model in this case, and then try them out.
Oh, the AI
And
Guild?
yeah, you
Yeah,
can run
yeah.
this one,
I started
This
yesterday.
one.
Tomorrow we
This
have
one.
another session.
and boom. And
I didn't record yesterday,
It's
but
over here,
I'm gonna
but,
start recording the session.
yeah, you can run line by line.
Okay, no problem. Yeah, I'll record everything. Are you like? Did you sign into like the
then after
Airtable
you
form?
download the data set,
I sent?
Yeah, I missed
and
that.
Try to.
you,
I don't think I sent it. Well,
yeah,
I'll show you how to get to that,
type
Yeah.
and that way, whenever I like post something, whatever, it will notify you directly.
now you can see it right here. California housing price.csv.
Explore would be kind of
Then-
more. It's like init FIU centered, and
Yeah, I will explain what
let's
this
say
does
it's
in a
catered more
second,
towards someone
but-
that's like learning from zero, from scratch, AI, and they've never had any experience before. Yeah,
What you
but
doing?
that's okay though.
Yeah, it's
Guild,
for the
What you doing, bro?
in Guild, we kind of dive into more like advanced
Yeah.
topics, and it's okay. Even like when I started in the Guild, not as a leader, like as a student, I was at negative. Like I knew nothing. I didn't even know like Python. So it's okay. Like that way, you still, you're still gonna learn new things. They might seem harder, kind of,
Yeah,
than
it's
this, but don't worry about it. I'd still say show up if you can. If not, watch the recordings. I'll make sure to record every. I didn't record the first one. I did post the slides, however, and all that. So I'll make sure to try to record from here on out. Yeah. But then what I was saying about, or what Kang was showing about the mean squared error, what we want to do, for example, we train a data. When we're training a model, we're literally training the slope of this line. What slope best fits these data points? To evaluate this, we want to see how far each data point is from the line that we made. So our goal with the error is to lower it as much as possible. If imagine like these data points are all the way out here and this line isn't, then the separation is a lot. So the error would be high, right? So we want to lower that. Again, that's in the case of regression. In classification, we have different classes. So here we have two classes, right? Either the data point is cold or it's hot. So it's one thing or the other. What we want is the probability that one thing is trending towards one or another. So due to the data,
yes, the sample data.
right? Due to the data, this is dummy data, right? 65 degrees, we're considering it cold. 68, we're considering it cold. Do you know Python? Okay. And then after 80, it's hot.
Just you open the.
So when we give something new, for example, 81 degrees, if this is kind of the line that we're trying to make, right? We're trying to make a line. Here's the decision boundary. We remember, so this is over the boundary, we can consider it. Yeah.
So basically, regression is that prediction that made what is gonna be prediction and the classification.
Classification, we put things into different classes. So for example,
Can be only two.
no, in this case, yes, logistic, because I'm gonna end up going over this. Logistic, we turn things into probabilities. So it's either a 0% chance that it's something all the way to 100% chance that it's something. We use it for two, but I want you to think of like images
I believe you can just run
of
that. Oh no. Wait.
like
Yeah, I
vehicles.
think
So we
you
have
try
cars, cars,
Yeah.
trains, planes, and I don't know what else,
yeah.
bikes, for example, right? When we classify, we want to, let's say we give the model a new picture, it needs to classify it into one of those classes. Oh, is this a plane? Is this a train?
You good, bro?
It's not, you know, it's
Yeah, yeah,
different from the regression
No.
that
You
that is,
need
the
help?
regression is predicting a continuous value. Here we make it discrete. We have different classes and we want to put this in a category. That's basically what classification is.
I
You got it?
got it.
Okay.
Yeah.
Perfect. Yeah,
Thank you so much.
no problem.
Oh yeah, what? How about the table? Later?
No.
Yes, right. I forgot.
Would you able to
Can you pull
access
up
the
the
data set?
Discord?
Well, I got
Yeah.
you a little late, but I've been just listening.
Oh. Oh, you
This
can.
is different. I'm trying to set up open call.
Oh.
How did you hear about the guild?
I just saw it and they're here.
Okay.
And then I know the David. He's a mentor.
Really?
Yeah.
Okay. Perfect. I know him
Yeah,
a
it'll
lot.
be
He
on
used to teach me
Notion.
Oh really?
in the guild. Yeah, because him and Gabe, they used
And
to
then
run
you
the
can
guild
download
last
this
year.
data set right here.
And
I just saw your.
Yeah, California housing price.
mhm.
This.
Download.
So
And you can go back to the
well, now I'm clicking around, but oh, okay. Here's the Notion site. Here we have all of our things. Tomorrow we meet. Unfortunately, you can't make it, but I'm gonna record it, post them on YouTube
and then
and whatnot. Here, whenever you need something, I always put them under these little boxes in the calendar, and
then you can
I'll put the slides and everything, right? In the slides, let's just go all the way. Oh, it was right there.
clear housing price, yes, yeah. And then you can run this with yourselves. Have you tried Google Colab before?
Scan this with your phone. It'll take you to a.
Like you know what it is?
I know it's like a browser ID, right?
That
Yeah,
way,
I know. Yeah,
in it,
is
National
yeah.
will assign you the
For
AI Guild member
testing
role,
out model
and that way I
research
can
as
tag
well.
you for whatever
Um,
announcements I have, and you actually get
Yeah, it's
notified.
also like kind of the same with
directly.
the Jupyter
I
notebooks.
think it should ask you
They also
name,
like kind of the same where you run code
Discord,
cells by
and
cells.
I don't think
Usually in the
maybe
normal IDE,
resume,
you just
but
run
don't worry
top
about
to
that.
bottom.
That would be
But in
like.
this case, you can take control of which
Do you
line
need
of
help with
code you
anything
want
else?
to run first. So
Do you need-
The table that you made.
Yeah, the Airtable. It's
yeah,
just like
yeah,
a form
yeah.
to sign.
You can actually, I can just run this and
That's
ignore the top,
probably
or
the most
ignore the one
important
on
thing
the
right
bottom.
now. That way I
And
can
then
reach out to you
I can just
and
run this and ignore this and just
link you to all the
run
videos and
the
everything.
one like right down here.
No problem.
Yeah, I can just start running this one without getting error.
Does anyone else need help with anything? I'll go to you right after.
I learned through machine learning. Yeah.
Oh,
Yeah. Before I was only
That's
do
interesting.
Java and JavaScript and
at least you get to see the
and C,
CSV file
but
straight up.
by just
Um,
learning machine learning and then I started.
okay, since none of
I
that is
LeetCode
working,
in Java.
let's try.
Yeah, because I
Is this
like
on
programming
Mac?
one and programming two was Java,
Okay.
so I started doing LeetCode with Java. Yeah, let me know if you have.
Okay, what would be? I'm sorry. Yeah. What would be like
What you
right?
doing,
Can you do? Can you right click it? No, same thing.
Print as or save page as is the whole page.
Do that.
Oh,
Yeah, because
apanya hả?
Không, em ở đăng kiểm không mấy.
it's
Ủa rồi hả?
You said this was right
Tại
click.
vì hắn mà mở apply thì phải cuối kỳ lần mà cuối
My bad, bro. I'm a Windows dude. Like,
I
I mean,
chỉ vẫn
has
quyết định
Kang,
apply.
Kang. Do you know Max?
Mac?
You use Max? I don't know anything about Max.
What happened?
When you click on it, it prints out the whole thing.
Oh, okay.
What's up, bro?
You good, brother? Yeah, look.
Oh no, you're clicking the thing and
Yeah,
it's
yeah,
opening
She
the
exactly.
page.
was using Mac, but then she was able to download it.
Yeah, put. I gotta start like
That's
I gotta
weird.
search up like a intro to Mac like.
I'll be there, bro.
Cause I don't know nothing about them, bro. I gotta find like a little YouTube video or something.
I guess. I was taking this from Calgo.
Yeah, maybe from there.
Yeah. What? You have access to the Explorer cohort channel on Discord?
I don't think so. No.
Oh. California housing. Oh yeah, as well. And
I tried like exporting it as well, but it didn't.
Did you get it?
Send it to Discord. What's your Discord?
Did you get it?
Yeah.
Okay. Perfect.
Mono, M-O-N-O.
Oh. Oh, you have the QR code? I think it's but I'll send it to Discord.
We're good?
Yeah.
Okay. What happened?
I need to send into Discord the dataset. I don't know, for some reason.
Does it happen to all the Macs?
No, for
It also happened to Lemon.
she have a Mac, but it worked on her,
That's so weird. I wish I knew.
and we both have a window.
Oh, bro, I'm sorry. I called you over because I thought you use Mac.
Wow.
I'm sorry. Yeah, I thought. I'm
Oh,
sorry,
okay.
bro.
No, no.
Some. Hmm?
Oh, okay. Alright. See you later,
Good job
bro.
on teaching so far.
Oh, thank you.
Good job, you too.
Thank you, bro. See
Thank
you.
you, bro.
See you guys next
Later.
week. I'll be here too.
Oh, okay. See ya.
Bro, can I scroll the collab on your computer?
Yeah.
Like to look at it?
Let's. And then just pass it into the sample data folder. Yeah. It's okay. Oh, it's. Right.
We're good to go?
Yeah. All right. So after downloading the dataset and try these two cells out, so I'm gonna go over what each line does. So the first line is to import the Panda module, which is basically a data manipulation module that Python have that usually used for machine learning purposes, that we can manipulate data to like make it 2D array, 3D array, or sometimes remove a column or a row just manipulating the data set. That's what it mainly used for. Then and online too, I import trend test split. So I import trend test split from a scikit-learn module, so that we can later on use this trend test split. We can use later on. We can use the trend test split method to split up our data to training and testing data set. And then for this line right here, the third line, what this does is that is go to the folder that we just passed the data set into. We're just going to the sample data and then accessing our data set file. And then it's gonna read that CSV file and pass all the data into this variable data right here. After that, we come to a process, as I mentioned before, pre-process the data. So data is not always perfect. It have no element. It's somehow missing column, missing row. So I want to go ahead and look to the data. In this case is a 2D array or a table. Look through that table and then remove any row that have no value. And then this function right here, this line right here, I use a drop NA. What it does is that it drop all the row that contain no data. And so it's go ahead and drop them. And then in place is true. So if we use drop NA alone, it's gonna take off the row that have the no value. But then after that, it's gonna go back to the same. So in place equal true, make it stay for that forever. So it's drop the no row forever. And then the data info, it just to print out this right here to look so that I can look into and see what is my current status of my data set. In this case, it said non-null value is 20,433 row. Yeah, so this all good, all equal in terms of row and column, and all non-null value. So my data set is pretty much good to go now. And then this line right here, X and Y. X is basically when we go to our data set. Right here, it have multiple row, multiple column. Each of the column represent a feature, such as in this case, the total number of rooms, the total number of bedrooms, the population, the household median income, etc. And then what this is going to do is that I assign all of these features into X beside one column, the median house value. The median house value is our target value that we want our model to predict, which is the housing price. This row is the housing price, median house value. So I take all this column and I assign all this column data into X beside our target value column, and then assign the target value column into Y, so that later on I can do further stuff with it. Well, we're just down here. In this case, X train, X test, Y train, Y test equal trend test split, X, Y test size 0.2. What this does is basically use this function right here, pass in the X and the Y, which is X is all the data column beside our target column, which is the column that have our housing price, and then the Y, which is the column that column is the housing price, which is our target value. You can see it as X is all the feature that we need, that our model need to make a prediction, and the Y is our final prediction goal, which is the housing price. Test size, I'll put it at 0.2, which means I want my test size to be 20%, and automatically the trending size, data set size will be 0.8, which is 80%. Y X train, X test, Y train, Y test. It's just a so what it does is it split out the data set into a training data set and a testing data set, and then from those two data set, it do the same process as well. So for the training data set, it take out all the feature column that is not the target feature column, put into X, and then put the target feature column into Y. Same thing to the testing data set. It take all the feature column into the X test, and then all the and then the target feature column to the Y variable, Y test variable. After that, what I'm doing here is to further. Right here, I only have split into two data set, which is training data set and testing data set. But I want best practice, which is 3 data set I was talking before. We talk about validation, test, training, validation, and test. So I need 3 sub data set. So I do split it again. Split it into 60% and 20%. Splitting the pre-existing 80% data set into 60% for train and 20% for validation. So I basically doing the same thing here, but now it's for training and validation data set. And down here is what we just did. We have a full data set with 20,640 samples, and then we divide into 80% and 20%, which is 16,512 samples to the training data set, and then 4,128 to the testing data set. We then go ahead to split up the training data set into 60 and 20. Training data set and the validation data set. So at the final end, we have beautiful data set, three data set of training, validation, and test set. Then we got to go to training our model. And this is another visualization as well. And here come the deep learning.
Okay, so now let's talk about deep learning. Deep learning is basically, I don't know if you guys have seen neural networks. This is a good example of a neural network. It's essentially the backbone of all the AI, like the AI boom that we have right now is all these neural networks. And we are gonna dive into what exactly makes these neural networks up. These are inspired loosely by our own biological structures. Each of these components in a neural network are called neurons or perceptrons. And this is basically what they look like. We have some input and we perform some kind of activation to it, and then we have some, from that activation, we get an output. And I want you guys to realize something quickly. Can I draw something up? So just very quickly to
This one.
all right. So we saw the example of what's it called? Linear regression, where we have, bear with me, I'm pretty bad at like iPad drawing, but we had this kind of example where we had our data points kind of lined up perfectly like this, and we had to find the line that best fit that through here. That's all pretty cool, but what happens in the instance where we have our data form some kind of, another shape? A line wouldn't describe that data set perfectly, right? We have to kind of shift that line a little bit so that it moves with the data. How do we do that? Well, that is through the use of activation functions. And this is basically everything that goes on inside of a neuron itself. So if you guys remember logistic regression, the shape of that line was this. It was not a straight line, it was this thing. And logistic regression mathematically is nothing but just a linear regression with a formula applied to it. So in neural networks and in deep learning, we have this formula that you're going to see all the time. We talked about y equals mx plus b. In neural networks, that m, we call it weights. And the b, we call it biases. So this m, we literally like flip it around and it's a w. And that is what is the input into a neuron. So we have now y equals wx plus b. This, again, in the instance of a linear regression, this just describes a little like a line that perfectly or tries to predict the data as perfect as possible. However, again, when we have nonlinear data, we have to have a nonlinear equation. Not to get too mathy, just to show you guys something, logistic regression is simply 1 over 1 plus e to the negative, and then what's in here, it's wx plus b. So we literally pass in a linear regression function into this, and this would output and change our resulting line from just some normal line like this to some probability curve like this. So in a neural network, we have, in this example, logistic regression, that was called the sigmoid function, is just an example of an activation function. And we are going to code our own this is the solution.
Yeah.
Oh,
That,
I think
oh,
so. Yeah.
you don't have to guess one.
So we're going to code this, just these neurons from scratch. So you guys can have the intuition of how a singular neuron works. And then as we go to the next workshop, we are going to, it's okay. So the plan was to code along. Accidentally, I guess, I put the solution document here, but that doesn't change anything. This is an example of our neuron. Our neuron class. Here again, I'm showing linear regression is wx plus b, and this would give us a resulting value, just like the graph that we had here. And then logistic regression, instead of just importing the module from scikit-learn, we can literally build it ourselves. We have the sigmoid function, again, 1 over 1 plus the exponent of the negative z, and the z in this case would be our linear regression. And what is a logistic regression? As I said, we have the resulting linear regression, and then we pass it to our sigmoid function. So how would a neuron work? Well, there's no point in deleting it at this point, but we have a list of weights, and then we have a bias. A bias would just be our y-intercept. And inside a neuron, we pass that linear regression through an activation function. Now, there's many activation functions. Again, in this example, we have the sigmoid function to represent logistic regression. Sometimes we just want some more binary activation function, and we'll go more into that next workshop. That is called ReLU, but there's no point in overthinking it. Just think activation function, it changes the shape of our line to better predict the data.
To more like better way to say it would be like make linear line into non-linear line, making a straight line into curve.
Yeah. So again, inside a neuron, what happens is just this code right here. Here's the individual linear regression code, individual logistic regression code. Boom, we put it in a neuron, and the output is our inputs would be the x values, our outputs would be the linear regression function with the activation on top of it. And if you run the cells, it will give just like a dummy example of how a singular neuron works. And yeah, so next workshop what we will go into is the neural networks in and of themselves. So now we pack multiple of these neurons together into different layers, and you guys will see how some really complex inferences can be made through that manipulation of these functions. Yeah.
And just to connect with Alex's explanation with the connection between linear regression and logistic regression. So right here, this is what usually like a usual neuron inside a big neural network look like. It have some input and it output something. But then in the middle of it, it have a cells, and this what Alex was talking about. On the right side right here, it's got divided by a line. On the left side right here, represent the linear regression, which is y equal mx plus b. In this case, it means the same thing. It still means the slope and the y-intercept, but it's just switching the variable, which is now y equal weight x plus bias. And then after you have that, we just represent for linear regression. It then pass it to a activation function, as Alex mentioned before, and this activation function represent the logistic regression, and it pass that linear regression into that logistic regression to make it like linear regression is a straight line, right? But then it pass it to the activation function. It then make it non-straight line, non-linear no more, so that with a straight line I would see before, it can it like oh, this will be a right here with a straight line before, you see it's not really adapting to the data, but then after like pass it through the activation function, can make it a little bit curved, make it non-linear, non-straight anymore. It now can adapt into the data, so it can learn the data better and then can make prediction better. Yeah, so that was the connection between linear regression and logistic regression. This linear regression right here, and the right side is logistic regression. And the output of it, as Alex mentioned, was the inside here is a linear regression, and then pass it through. This right here is like a function, activate, which is the activation function. Pass it to the activation function, and whatever the result of that will be the output of a single neuron. And to come back with the logistic regression, let me see, where did we use sigmoid? Did we use sigmoid? We use sigmoid in this.
So in the logistic regression, again, this is a module we import. These internals aren't shown to you. We show it from scratch here, for example, right? So again, the sigmoid function, it turns that line into that little curve, nonlinear, and yeah, so you pass through a linear regression, the one that we made right here. That linear regression result is the input to the activation function sigmoid, which basically squashes that line, and that is an example of an activation function. And here you see it within a class. For those, I guess, who don't know Python, you initialize the class. We have the weights and the biases. In this case, it's like the slope and then the y-intercept. We have a function within that class called activation. In this case, it's the sigmoid function. And a forward pass means basically what happens when we through one pass of just think about going forward. We get the output, we bring it in, and then whatever comes out. How does that work? That is the w times x plus b, the linear, and again we apply the logistic regression on top of it. And yeah, that's a brief intro to neurons and neural networks. that we will go into more deeply into next workshop. Which next workshop, what we will do is like a simple computer vision program through neural networks. So if you guys have heard of an MNIST data set, we'll basically learn to recognize handwritten digits, and we pass those images through our neural network, and we will get an output telling us what that digit is. And yeah, pretty much that's what we got for today. A little shorter than we expected, but still we went through the information.
Anyone have any question we can answer to?
So you said the single neuron gets data, sorts it into the linear regression, transform it.
Yes.
Yeah.
But then that goes go to the next layer of neuron.
Yeah.
Which
does the same thing.
Which is the same. We're just doing the same process again. So like this is, let's say we started from here, and then after we do that, put in we have an input data, put through a linear regression, y equal weight x plus bias, and then pass it to an activation function. The output of that will then go to the right here, the next layer of the neuron, and then it then again doing the same thing again. Whatever the output of the last layer of neuron going to the input, the next input layer of neuron. That will be the output of the last neuron will be the input of the new neuron, and then it will do the same thing, pass that data it just received into the linear regression y equal weight x plus b, and then pass it to a activation function, and then output it, and then pass it to another layer of neuron. Yes, it's passed to another linear regression inside. Each of the neuron is basically linear regression and logistic regression combined. Each of them. So the process will be the same throughout the neural network. Yeah, but then after we passing through it, let's say for the first time, it's not always going to perform very well. That's why we need to go back and then adjusting. For example, in this case, will be the weight and the bias. It's something we can adjust so the model can learn better, and that will be, I think, covered next workshop, which is that process is called backpropagation, which is after one pass the neural network, it then go back to each of the neuron to see where it's got wrong, and then it changed the weight and the bias of each of the neuron, so that it perform better, and do that with every single neuron in that layer, and then from right to left, every single layer of neuron, and until it do that, until it reach to a optimal, like a decent accuracy that you want to stop. Is at the end is your choice to say when the model should stop. Any more questions? We have like 17 minutes left, so feel free. I guess we done with it today. Thank you guys so much for coming to the first workshop of the AI ML cohort. Really glad that you guys was able to make it here today. Looking forward to see you guys next workshop, where we dive into neural network, of how a bunch of these neurons combined together perform a significant task. Yeah, and also we're gonna dive into a different type, a specific type of neural network, which is CNN, or convolutional neural network. Is a specific type of neural network to deal with images and video. So that will be related to our final project. Yeah.
Thank you.
Thank you. I thought I delete this. Wow.
Let me stop.
Thank you.